Hello and good morning. In this video today we're going to talk about the possibility of life and specifically what are the basic needs to survive on Mars. Let's start. First of all, we need to understand that Mars is one of the 8 planets in our solar system. It is positioned in the 4th place starting from the Sun. But how was Mars formed? When was it discovered and why are we interested in this planet? Let's see. It was formed approximately 4.5 billion years ago, when gravity pulled dust and gas together and formed the planet that we know today as Mars. Its structure is conformed by 3 parts. First, we have the central core, which is believed to be solid, since most of its magnetic field has disappeared. This is then wrapped in a rocky mantle, which is composed mainly of silicon, oxygen, iron, and magnesium. Finally, we have the crust. It is the dust that covers the surface of Mars and it's mainly composed of volcanic basalt rock. The first observation of Mars was by Galileo Galilei in 1610 with a primitive telescope, being also the first person to use it with an astronomical purpose. Then, in September of 1877, an Italian astronomer named Giovanni Schiaparelli published the first map of the surface of this planet. These maps contain features he called canals, which were long straight lines on the surface. The Diran calendar is a system of timekeeping designed to serve the needs of any possible future human settlers on this planet. It was created by Thomas Gangle in 1985. But why are we so interested in this planet? Being located in the habitable area of our solar system as well as Earth, it has become really interesting to investigate possible life on Mars. Global warming also plays a really big role in finding a new home for humans due to changes in climate and composition of Earth. And now, what do we need to live on Mars? There are 4 known challenges that we know so far about living and traveling to Mars. In the first place, we have the challenge of finding water. There is evidence of water in Mars' soil and atmosphere, and astronauts may be able to extract it from there. This process could be done through a perchlorate, which is presented all over Mars. Perchlorate is a physical-chemical process such as an ion exchange or a reverse osmosis. The problem with this is that it can produce a lot of waste. The second challenge is staying warm. Since Mars is further away from the Sun, it means that it is way colder than Earth. The Martian atmosphere is less thick than Earth's atmosphere, which is why our planet is warmer. At the equator of the red planet, the temperature at noon feels like a cold winter day in Earth, this being 0 degrees Celsius, but at night it could reach minus 175 degrees. This is 4 times colder than Antarctica. In the third place, there is the challenge of growing food.
Even though Mars' atmosphere consists mostly of carbon dioxide, an essential gas for plant survival, and Martian soil has the essential nutrients for plant survival, the problem is that nutrients depend on which area of the land astronauts land. Fertilizer may be needed. Also, we need to protect plants from the harsh temperatures that we talked about before. Finally, in 4th place, there's a challenge of blocking the sun's radiation. Earth has a magnetic field known as the magnetosphere that protects humans from the strong radiation and, as mentioned before, a thick atmosphere that also protects us from radiation. But Mars has no magnetosphere and its atmosphere is 100 times thinner than Earth's. Since radiation is a cause of cancer, humans cannot go without necessary protection, so we need to have in mind the construction of special habitats, suits, and machines that could protect us from the radiation. There are 5 evolving science strategies for Mars exploration. The first strategy is to determine if life ever existed on Mars. It is likely that if life ever arose on Mars, it will require a supply of water that was present for a considerable period of time. The second strategy will be characterize the current and past climate of Mars, as well as the factors that influence climate change on Mars. The third strategy will be characterize the geology of Mars. Rocks can help scientists describe the sequence of events in the history of Mars, determine whether there was an abundance of water on the planet by identifying minerals that form only in water, and determine if Mars ever had a magnetic field, which will point Mars at one point being a dynamic planet similar to Earth. The fourth strategy will be prepare for human exploration of Mars. This presents a huge engineering challenge, since the surface of Mars contains superoxides and also the planet lacks a magnetosphere and ozone layer to shield itself from the sun's radiation. Scientists will need to fully understand as much of the dynamics of Mars as possible before taking any action towards the target to put humans on Mars. And finally, the fifth strategy will be technological exploration of Mars. This is through robots that NASA sends to Mars. There are architectural projects that seek to create a city that will simulate the habitable conditions of Earth and Mars. In this way, constructive strategies for living under the radiation and cold conditions of Mars will be investigated and tested. This futuristic city is called Lua, a sustainable city that has been thought of being constructed with materials found on Mars, because of the challenge that can be transporting heavy construction materials to Mars. Also, the city is thought to solve the 4 known problems of living on Mars that we mentioned before. It is scheduled to begin construction in 2054. To summarize, Mars is a planet that has a lot of potential in terms of minerals, geography, and environment. If the main 4 challenges, warmth, water, foods, and radiation, are controlled, future explorations and even settling could be successful. This way, a part of humanity could have the possibility to live in a planet and enjoy the facilities of the red planet we call Mars.